in this episode how to simplify radicals or roots. Coming up. Stick around until then. Hey guys, in this episode I'm going to break it down how to simplify radical expressions or expressions involving roots. So in maths, radical and roots it's kind of the same thing. So anything what you have like square root, it could be cubed root or other roots. So stuff like this. Let's take a look at a few. If you are given something root of 12, alright, you need to simplify it down. You need to make it simpler. What does it mean? What do I mean by this? So you need to get the smallest number possible under the root symbol, under the radical symbol. So when you have a number like this one, 12, or it could be larger, but the thing is, try to break it down, this number which is underneath your root. But what you want to do, you want to isolate a perfect squares. What they are. So basically a perfect square, it's a number that has another number that get multiplied by itself, gives you back that number. For example, 4 is a perfect square since 2 times 2 gives you back 4. Next, 9 is a perfect square since 9 is expressible as a 3 times 3 or 3 squared. 16 is a perfect square, next one, since 4 times 4 gives you back 16. List goes on, blah blah blah. Now, for this 12, let's figure out. 12 can be expressed in many different ways, but we need to take into consideration this perfect square. In this case, 4 is a perfect square and 12 is divisible by 4. So 12 can be expressed as a 4 times 3. Since if you divide 12 by 4, you would get 3. Why we need these perfect squares, if you want it? The thing is, after this we can break this root down into 2 roots. Root of 4 times root of 3. Since 4 is a perfect square, this root simplifies to just 2. Since 2 times 2 gives you 4. That's why we need them. We need these perfect squares to pull them out, kind of, from the root. Now, check to see. 3 is actually a prime number. What they are? Prime numbers, numbers that accept 1, actually. They have only 2 factors. They have 1 and itself. So 3, it's a prime number under roof. And it cannot be simplified any further. So you would end up with 2 root of 3. Again, at this point, check to see if you can simplify any further, if any more simplifying can be done. At this stage, no, since 3 is a prime number, to take it out, this is your final answer. Moving on. You have root on top and you have root on bottom. What you can do, you can combine, you can use kind of properties of root, if you will, and you can write that big root and put this fraction under this root. Now, this is the property of root that I used. Now, 27 you can divide by 3. And we are left with just 3. So you keep this root as well. When we end up with just 9. Again, now 9 is a perfect square, since 3 squared gives you 9. So this root can be reduced just 3. So here we are talking about just principal square root, so we are not taking this negative in front. So it's just positive value of root. Moving on. You have one root added to another root. Let's just do it incrementally. For the first one, 28. It's divisible by 2. It's also divisible by 4. So I can use this 4 because 4 is a perfect square. So express 28 as 4 times 7. Moving on. How about 63? Keep addition. For 63, you would have 9, which is perfect square, times 7. Now, at this stage, like we did before, we can break down these roots. Since 4 is a perfect square, the square root of 4 is just 2. And square root of 9 is just 3. Now, you have 2 root of 7 added 3 root of 7. Since you have the same number under the root, you have 7 and 7 there, we can combine them. They can be added to each other. So 2 and 3 gives you just 5 root of 7. Sometimes they are called like terms, like because they have the same, precise the same number under the root. So they can be combined. Whereas unlike roots, so if you have like another number underneath the root, so they cannot be combined. Moving on. How about this one? Alright. You have a number 2 out front, 2 gets multiplied by third root of 2 and all this thing raised to the 6th power. Now, a bonus tip. You have to raise all this part of this equation to this power 6. Many people forget to raise 2. This is vitally important. So 2 has to be raised to this power 6. And this whole entire root has to be raised to the 6th power. So this is another property of power. Sometimes it's called factor power rule because you have 2 factors multiplied together. Now let's evaluate this one. 2 to the power of 6, just 64. You can just multiply it since 2 to the 5th is 32 and you multiply by 2, or you can do just this math by hand, off to the side, or if you are allowed to use calculator, you can punch it and get this value. Now, let's tackle this one. This root can be expressed as power on power rule, but in the inverse order. Since when you apply power on power rule, you have to multiply these two exponents straight across, so that gives you 6. Now, the third root of 2 raised to the 2, you could think of this third root and this power kinda cancel each other out. And you would get just 64 times 2 squared, which is basically 4. 64 times 4 gives you just 256. This is your answer for that problem. Rationalizing the denominator. What is that? Apparently, basically, it means that you want to get rid of, you want to remove this root from your bottom, from the bottom of your rational expression. So sometimes you are given a root, a radical, which stays in the denominator, in the bottom of your expression. So when you want to get rid of this, when you want to remove it, that's called rationalizing the denominator. Why do you want to remove it? Why do you want to get rid of this? Well, your expression in maths are considered to be simpler when you don't have the root, when you don't have a radical sign, a radical symbol into the denominator. So, if you are given something, just a number placed on your top, and you have a root, it could be root of 2, root of 3, root of 5, blah blah blah. So it's not a perfect square, otherwise we would just evaluate it immediately, instantly. So, and we want to get rid of, we want to remove this root from the denominator. There is a special trick, there is a special technique that you need to apply here. What you can do, you can multiply top and bottom by the same bottom number that you are given in your problem. So in this case, you multiply top and you multiply bottom by root of 2. Why you need to multiply top and bottom? Because you don't want to change the overall value of that expression that you are given. You want to keep it the same. Now, why it helps us? Why it solve? Why it eliminate this root in the denominator? Because immediately after, in your denominator, you would have just root, and you need to multiply these 2's straight across. So, because it's the same number, it's just 2 squared, or any number squared. So that's why you can eliminate, you can get rid of this root from the denominator. So it becomes just 2. And your top becomes you multiply straight across these top numbers. So since bottom is just 2, it becomes 6 root of 2 over 2. All you need to do is just check to see if you can simplify this expression any further. Sometimes you might have the common factor that could cancel. So in this case, 2 goes into 6 3 times, and we are left with 3 root of 2. You see, at this point, at this stage, there is nothing in the denominator. There is no denominator, actually, it's just 1. It's implied to be 1. So we eliminate this root from the denominator. Moving on. How about this one? This is slightly different from here. So here you have a number added to root. So we want to get rid of this root from the denominator. Here all you need to do is just use another trick, another technique, another strategy. You can multiply top and bottom of this expression by the conjugate. Conjugate. What is the conjugate? Conjugate it's just the same expression as your bottom, but the difference is you flip the sign in the middle. You change it to the opposite. So in this case, you multiply top and bottom by 2 minus root of 3. So again, you have to multiply top and bottom simultaneously, because we don't want to change the value, the overall value of this expression. And you need to draw the parentheses. You need to include it within parentheses. So again, the conjugate expression, it's the same basically expression as your bottom, but the difference is the sign, the middle sign flipped, switched. So if it were negative here, minus, you would write plus between. So in our case, in our problem, we have plus. So we wrote minus. Now, what does it give you? You have something like a plus b, a minus b, and you might spot this formula here. It simplifies to a squared minus b squared. So in this case, it's gonna be 2 squared minus root of 3 squared. And precisely this piece gives us this kind of a to get rid of this root. So it becomes just 3. And you keep this top as is. So 2 gets multiplied by 2 minus root of 3. Now, just let simplify the bottom expression. 2 squared becomes just 4 minus 3, and you end up with just 1 in the denominator, so no root at all. So your final answer for this one is just this top. Again, as you can see, there is nothing in the denominator, so we eliminated this root, so we got rid of this. So this is just kinda little tricks, little techniques to rewrite your expression without any root in the denominator. I hope it helps. I know everyone hates math, but if you like my video, please click like, share with your friends, leave the comment down below, and smash that subscribe button so you will not miss my new videos. Train your brain.